All right, let's try to compute a probability given a normal distribution. So in example 3.8.3, the length of human pregnancy is normally distributed with a mean of 272 days and a standard deviation of 9 days. State the individual, variable, type of variable, and random variable x, and list the givens with the correct symbols. Okay, so here the individual will be a human pregnancy. The variable will be the length of human pregnancy in days. And the type of variable, since length is a unit of time that's measured, so this will give us quantitative as far as the type of variable. The random variable x is the length of a randomly selected human pregnancy. And the given values are the population mean mu, which is 272 days, and the population standard deviation sigma, which is 9 days. All right, so there we have it. The individual is a human pregnancy. The variable is length of pregnancy in days. The type of variable is quantitative. Why? Because it's measured in length of days, and that's something that's measured. The random variable x is the length of a randomly selected human pregnancy. The givens in this particular problem are the population mean, mu sub x, 272 days, and the population standard deviation, sigma sub x, equals 9 days. All right, let's look for what else they want in this particular problem. That's the setup. Find the probability of a pregnancy lasting more than 280 days. So let's go ahead and first put this in correct notation. So probability, we're going to assign capital P. The random variable is the length of pregnancy, that's going to be x, and it's going to be more than 280 days. So if I annotate this kind of above the sentence, here's P for probability. The pregnancy lasting, that's the number of days, that's going to be my variable x. Here I'm going to put a greater than symbol over the word more, and then here I have 280. So here I've got P, the probability of what? The random pregnancy, x, having a length greater than 280 days. So that's my notation for this particular problem. Probability of a randomly selected pregnancy being greater than 280 days. So that's what I'm after as far as the probability statement. So here I'm going to use the normal CDF. So here I'll actually just type out, what my inputs will be here in the normal CDF function. All right, and that's going to be, the lower value is 280. The upper value is, I'll skip that for right now. The mean is 272, and the population standard deviation was 9. All right, so I'm going to draw a picture here. Now again, you'll have to bear with me because this is your math professor's attempt at art here. So there's going to be my normal distribution. And notice it goes off forever to the left and to the right. At the middle is the population mean, and that was 272 days. So this is pregnancy length. Okay, and the standard deviation was 9 days, so I think I can add 9 to 272. I get 281, so that's going to be right at the transition point, 281. Right, notice right there is where it changes from hilltop to valley. And 272 minus 9, that's going to be right here. Let's kind of eyeball that pretty close. Okay, so that's going to be 263. Okay, and so I could put more tick marks if I go another 9 units out here. This would be at 290. Sorry, this is in units of days. And if I go out to the left and right about there, that would be 254. Now, I'm going to shade in on the graph what greater than 280 looks like. So I've got 281 indicated, so I'm going to choose a different color marker here. Let's go with blue, let's say. So here, we'll call that at 280. and I want greater than, so I'm going to shade everything to the right of that. Now this is a theoretical model given by that particular equation. So technically this graph goes forever to the right. Okay, so over here off to the right would be infinity, and right here would be 280. Okay, so how do I indicate infinity on my calculator? So here's where I'm going to input 1, well, 10 to the power of, here's my caret symbol, and I'm going to put 99. So that will serve as, such a large number that it's approximating infinity there. So that'll go right there. So now on my calculator, so I'm going to go ahead and bring this to the left. And if I had, if I had a home screen and I wanted to start from scratch, second vars, option 2, normal CDF. The lower value on my graph is 280. The upper value, well, I can't put infinity into my calculator, so I'm going to put instead 10 to the power, there's my caret, 99. The mean is going to be 272, and the standard deviation is 9. I'll hit enter and paste. So there's 280, 10 to the power of 99, 272, and I had a 9 at the very end. So hitting enter there, 18.7% is going to be the area underneath that curve. So here I'm going to approximate to 3 decimals here, approximately 0.187, and I'll put this in terms of percent, 18.7%. So the probability that a human pregnancy lasts more than 80 days, 280 days, is going to be approximately 18.7%. And let's just look at 280, that's what we had on the calculator, upper value 10 E99 when I entered that in. The mean is 272, the standard deviation is 9, and sure enough, to 3 decimals it's 0.187 or 18.7%. So let's go ahead and interpret this. So notice there's the notation I had above, probability of a random pregnancy having a value greater than 280 days. Here's what literally I entered it in the calculator. I'm going to use the normal CDF function, lower value of 280, upper value of 10 to the power of 99, that's approximating infinity, 272 for the mean, and the standard deviation is 9, is approximately 0.187 to 3 decimals. So how do we interpret this? There's 2 different interpretations. We can interpret this for a random individual, and we can interpret it for the entire population. So if I were to interpret it for a random individual, I would say something like the probability that a random individual human pregnancy is more than 280 days is 18.7%. If I interpret it for the entire population, I would say 18.7% of all human pregnancies take longer than 280 days. So both of those interpretations are correct. You can interpret it for an individual. The probability of a random individual having a pregnancy more than 280 days is 18.7%. Or you can interpret it for the population. 18.7% of all human pregnancies last longer than 280 days. Let's go ahead and write both of those up. One interpretation for an individual and one interpretation for the population. All right, here I've got it written up now. There's an 18.7% chance that a randomly selected human pregnancy lasts more than 280 days. That's for an individual. And for the entire population, 18.7% of all human pregnancies last more than 280 days. So one interpretation for everyone, that's all, and one interpretation for a single randomly selected, so a randomly selected pregnancy. All right, so let's go on to the next part. Find the probability of a pregnancy lasting less than 250 days. So now we're going to, again, write this in symbolics. Symbolics, that's not a word, in symbols. So P for probability. Oops, and let me go ahead and bring up the ink that I was using. Human pregnancy less than 250 days. So there's the less than symbol with the word less. Human pregnancy, the length of that's our random variable. So the probability that a human pregnancy lasts less than 250 days. All right, so here I'm going to have, there's my notation. I'm going to bring in the normal CDF function on my calculator. Normal CDF. And I know what the last two entries are. The last two entries are going to be the mean, 272, and the standard deviation of 9. Okay. I need the lower value and the upper value. So I'm going to draw a picture here. Let's see. And I'm getting a little bit sloppy. It's not going to be as beautiful as my other one, and that one was not very good. Okay, so at the center is my population mean, 272 days. And here, one standard deviation is 281. Another standard deviation is 290. On the other hand, standard deviation to the left is 263. And one more standard deviation to the left is 254. Okay, and here, specifically in this example, we want less than 250. So I'll find 250 approximately, somewhere over here. And I want less than. So I've got the area and that little bitty left tail over there. So that's what the probability as far as the area under the curve will represent. So here, I want the lower value to go forever off to the left. So over here, way off to the left is minus infinity. So in place of that, I'm going to use 10 with a negative, minus 10 to the power of 99. So when I type this into the calculator, it's going to be negative 10, and then I'm going to type the caret and then 99. All right. The upper value is going to be the value on the right, which is 250. So right there is going to be 250. All right, so let's go ahead and enter this into the calculator. So bring this over to the left. And here, I'm going to go to second the vars key, normal CDF. And so the lower value is going to be negative 10 to the power of 99. Okay, so the upper value is 250. The mean stays the same, 272. The population standard deviation stays the same at 9. So that's what it looks like in the calculator. All right, and now hit enter, and 0.0073 to 4 decimals. So this is approximately 0.0073 to 4 decimals. As a percent, that's 0.73%. All right, so let's go ahead and give an interpretation for this. Okay, notice this is what we had in the calculator, just making sure we have the same. And to 4 decimals, the fourth decimal is a 2. Look to the right, it's a 5, so we round up to 3. All right, so again, the interpretation is going to be similar to how we did this for the previous example. So I can interpret this probability as the probability for a random individual pregnancy, or I can look at as interpretation for all pregnancies. So I could say there's a 0.73% chance that a random human pregnancy would last less than 250 days. That's interpreting for an individual. Or if I interpret that probability for all of the population, I could say 0.73% of all human pregnancies take less than 250 days. So let's go ahead and write that up below. All right, so here's the interpretation for a randomly selected individual. There's a 0.73% chance that a randomly selected human pregnancy lasts less than 250 days. Or we could have interpretation for all pregnancies. 0.73% of all human pregnancies last less than 250 days. All right, so we've had one particular scenario where I had the probability of x being greater than a value. This example, I had a probability of x being less than a particular value. The next example will be a probability of X being between two values. So let's look at that example now. Find the probability that a pregnancy lasts between 265 and 280 days. So here I'll go ahead and immediately start annotating this. So here, probability, I'm going to replace that with P. So the length of pregnancy is X, and I've got between 280 and 265. So the probability of X, meaning the length of a random pregnancy, being between 280 and 265 days. So if I go ahead and use the calculator, I will be using normal CDF, and the lower value will be 265. The upper value will be 280. The mean is 272, and the standard deviation is 9. And this is approximately, well, let's go to the calculator. So second VARS, option 2, normal CDF. The lower value here is 265. Upper value is 280. And the mean and the population standard deviation stays the same. So here we're getting about 0.5946 to 4 decimals. So I'll go ahead and edit that. So this is approximately 0.5946. And if we want to state that as a percent, we can easily do that. This is approximately 59.46%. Now, if I drew a picture of this scenario, I'm going to draw the normal distribution. At the center is the population mean of 272, and I'll quickly put in one standard deviation over at 281, and then one more at 290. Going to the left, 263, and one more left, 254. So we wanted between 265 and, so that's about 265 and 280. So we're right about there, and so we're shading in that particular area. So that's going to represent approximately 59.46% of the area there. So as you can tell, I must have drawn a really bad normal distribution curve, again doing this by hand, because that blue shaded region doesn't look like 59.46%, but again, you can blame my bad art. All right, so again, this is what we had for the calculator. Lower 265, upper 280, 272 for the population mean, and 9 for the population standard deviation. Here to 4 decimals, it's 0.5946. Here in this particular example, they rounded to 3 decimals. I'm going to go ahead and pause and go ahead and write your 2 different interpretations of this particular probability of 59.5% if we round to 3 decimals. And then unpause it, and we'll take a look at my interpretation. All right, so hopefully you've written something close to this. The interpretation for a single human pregnancy: there is about a 59.5% chance a randomly selected human pregnancy lasts between 265 and 280 days. Or the interpretation for the entire population: 59.5% of all human pregnancies last between 265 and 280 days.